Those of you who know me and have taken some of my workshops know that I'm a big fan of paste solder. I use it in virtually all of my filigree creations and all of my other jewelry creations as well. But some jewelers think that paste is not a great idea for hand fabricating jewelry. Some of the negative things I've heard from other jewelers are paste solder creates porous joints, so it's not as strong as sheet solder. And because paste solder creates these porous joints, solder seams will show up on rings. So in this video, we're going to see if these claims are true by doing a couple of different tests with 3 different solders. The solders that I've chosen for testing are ones that I use in my studio, and those are Rio Easy Paste Solder in a 1-ounce container, Pepe Tools Easy and Hard Paste Solders in syringes, and chips or pallions of Rio Sheet Solder, both easy and hard. So let's look at the first test, the earring post/finding test, where I'm going to simulate soldering on earring posts. I prepared a series of square sterling silver test blanks, 18 gauge thick. I stamped them with the type of solder that I would be using and the gauge of wire, either 18 or 20 gauge. For example, P2 is Pepe Easy Paste with 18 gauge piece of ground wire. I then soldered each wire onto a corresponding blank using the indicated type of solder. This is one of the blanks after soldering and cleaning. The next step is to see how many times I can twist the wire before the solder joint broke. I use my graver ball to help me do the twisting with consistency. In this test, I twisted 18 gauge wire.
1, 2, 7, 8, 15, 16.
In all of the solder earring post finding tests that I did, I found one thing. In every single instance, the break was not on the solder, but it was above the solder. So actually, the piece of sterling wire that I was using in the tests broke before the solder joint broke. And so I just want to show you with a close-up what that really looks like. Let's have a look at one of these.
So here are the 6 test pieces that I used to run the earring post finding test. What I found was that in all instances, the post broke and the solder didn't fail. And I picked this one. This is the Pepe Tools hard solder one. And I'm picking this one just because it's a really good example of this. And you can see that here's the solder. The solder joint's absolutely fine and very tight. Right? It's very tight. It didn't loosen. And that the post broke not at the solder, but actually a few millimeters up on the length of the post. And all of the other pieces look like this, maybe not identical. Some of them broke right at the top of the solder. But in every case where the post entered into the solder, the post is still there and it broke above the solder.
This chart shows the results of the finding twist test. With only one exception, all of the wires broke with between 12 and 16 twists. And in all cases, the failure was above the solder joints, so none of the solder joints failed. Even with P1, which broke with the fewest turns, the failure was above, not in the solder joint. So we can summarize that the post generally broke after 12 twists or more.
None of the solder joints failed. The failure was always in the wire, and both paste brands and the sheet solder chips performed equally well. So the grand conclusion is that sheet and paste solders, as well as easy and hard solders, are equally suitable for attaching earring posts and other findings.
We now move on to the next test. The purpose of this test is to simulate one of the joints of a resized ring, or the closing joint of a new ring. Once again, I prepared pieces of 18 gauge sterling silver sheet and carefully sanded one end of each sheet to prepare them to be soldered together. Here I'm soldering together two of the prepared samples of sterling sheet using Pepe hard solder. I purposefully used some excess solder to assure that the joint was appropriately filled. I then sanded the excess solder off one side and then followed up with a light polishing with tripoli. Once satisfied that all were appropriately soldered, I proceeded to the bending test. The idea here is to stress the soldered joint, likely much more than we would typically ever stress such a joint.
And then I'm going to hammer it over. And as I said before, way more stress than you would ever really expect a ring joint to experience. So I'm just going to clean it before we look at it. And let's get this right up to the screen. The seam should be right here, right? You can see the difference of the two thicknesses of the metals, and I don't see a seam on this one anywhere. Here are all of the pieces that I prepared for this test. I've examined each one carefully and can't see the solder seam on any of them. That's because the 5 different solders that I've used in this test have worked beautifully. So in summary, none of the solder joints is visible. None of the solder joints failed during the bending test. All paste and chip solders performed equally well. So it's safe to conclude that all of the solders tested are equally suitable for soldering ring bands and are suitable for other similar tasks.
So now that we've done all these tests, what have we actually learned? Well, we tested 3 different solders: Rio paste, Pepe paste, and Rio sheet soldered chips. With all 3 solders, we tested easy, and with the Pepe and the Rio sheet chips, we also tested hard solder. In the tests that we did, all 3 solders worked equally well on all tasks. You may recall at the beginning of this video, I listed some of the negative things that I personally have heard about paste from other jewelers. Comments such as, paste solder creates porous joints, so it's not as strong as sheet solder. And things like, since paste joints are porous, solder seams on rings will be weak and they'll show up on the rings. I believe that we've now proven all these statements to be completely incorrect. I've been using paste solder on all of my filigree jewelry and my other jewelry for well over a decade, and I found it to work very well. I almost never use sheet solder in my studio. Hopefully, after viewing this video, you'll consider using paste in your own studio. If you have any questions, please put them in the comments, and I'll try and get back to you as fast as I can. I hope you found this video both interesting and useful. I'm planning to create more videos on paste solder and other jewelry topics. To make sure that you don't miss them, please follow me on Instagram and YouTube. This is Milt of MF Metal Arts, and thanks for watching.